Yeah, online students can hear me? Uh, so last class we have completed tree set. Tree set we understood with the comparable interface. Now we need to learn comparator. So tell me, comparable is used for passing default sorting order logic. Comparator is meant for passing custom sorting order. Okay. Okay. Custom sorting order means one point you have to understand. I am giving you objects. The order you want to store, it is your wish. I want my student objects should be sorted based on the student number. But you, other developer, wanted to store those objects in a different order. Then, if you want to store in different order, you have to supply the logic now. For example, I am taking string class. Who develops string class? Sun Microsystem. Sun Microsystem has developed student string class by overriding comparative method, storing objects in ascending order. But I am the user of string class. I want to store string objects in descending order. Here, string objects is nothing but what? Name. I want to store student names in by default ascending order. String class has have the logic. But I want to store the objects in descending order. Then can I go to string class, comparative method, change the logic? No. Then what I have to do? I must change the logic by myself. Okay, I have to supply the logic by myself. So if you choose the treeset class constructor has the third constructor, what? Comparator. So it is asking us to pass comparator implementation class. Comparator implementation class can be provided in how many ways? Okay, look at that. Constructs a new empty tree set sorted according to the specified comparator. If all elements inserted into set must be mutually comparable by specific comparator, comparator dot compare of element 1 comma element 2 must not throw class cast exception for any element E1 and E2 in the set. If user attempts to add an element to the set, those violates this constraint. The add call with throw a class cast exception. Okay, that's all implementation part I will tell you. So what the point I'm trying to tell? Very important. Constructs a new empty tree set sorted according to the specified comparator. So you in which order you want to store that comparator you have to pass. If I use no param constructor, it uses which interface? Comparable. If you don't like default comparison, you must use what? Comparator comparison. Okay. Now let me try to write the code for storing string objects in sorting order, reverse sorting order, nothing but reverse default sorting or nothing but descending order. Help me to write the code. First, I have to create what? Tree set, tree set, tree set, TS. Okay, what type of objects you want to store? String. TS2 equal to new tree set, new tree set, new tree set. What I have to pass? Comparator. How many ways we can develop comparator? First, understand what is comparator. Comparator is what? Comparator is a interface. What is that interface? It is a business logic interface or a functional interface. It is a functional interface. Look at that. It is a functional interface. Functional interface can be implemented in how many ways? 4 ways. What the 4 ways? Number 1, by using outer class. Number 2, by using anonymous inner class, by using lambda expression, by using method reference. So there are 4 ways we can develop functional interface implementation. Outer class and anonymous inner class approaches are outdated. Already you know, you have learned in functional programming. Now what we are using latest version? Lambda expression. So I want to provide a lambda expression to sort string objects in descending order. Tell me, sorting string objects in descending order means you must compare or you must subtract. Adding object minus already available object means new object minus already available object. If I store new object minus already available object comparison, then it is stored in ascending order, no? This is ascending order. Now you want descending order means what? Reverse. What is the reverse? Already available object minus new object you have to write. Then objects are stored in descending order. Understand? That means from the comparative method point of view, compare method point of view, compare two method point of view, current object minus argument object, it leads to what? Argument object, it leads to what? In which order it will store? It will store in ascending order. If you store ascending argument object means already available object, argument object minus compare current object, then the objects will be stored in descending order. So these orders you got to remember. Already last class you have written notes also. Okay, which order? If you want to store objects in which order, which subtraction you have to do, and tell me now what is the method available in comparator? The method is what? Compare. Compare first object minus second object. Tell me here object 1 is current object, object 2 is what? Argument object. Inside compare to method implementation logic, what I should write? Return current object minus argument object, ascending order. Argument object minus current object is what? Descending order. Tell me now, I wanted to store string objects in descending order. For that, I have to supply custom comparator. How many ways we can write custom comparator? First, I am taking string descending comparator. String descending comparator. Okay, this is what? Class name. Class name means I have to create a outer class or not? Now F3. Now look at there, F3. There is already a class I have created already. Okay, string descendant comparator. Let me delete it right once again so that you can easily understand. I am deleting this. Public class. What do you write? String descendant comparator. What is implements comparator? Implements comparator. Okay, tell me in this method which type of object you want to compare? String type, open bracket. Which method you should implement? Compare. Compare method with what parameter? String s1 and string s2. Why string s1? Because you mentioned the type string now. Okay, what is the logic you should write? I want to store objects in descending order. So second object dot compare to of first object. Okay, s2 dot compare to of. Already in string class compare to method is there to compare string characters with a subtraction operator. Na? So you no need to use a minus operator. Simply you have to use what? Compare to method. s2 dot compare to of s1. Then after this, after creating custom comparator, pass that custom comparator, add the object. ts2 dot add of what I should pass? Double quotes A semicolon. ts2 dot add of double quotes C semicolon. ts2 dot add of double quotes B semicolon. System dot out dot println of. Okay, what do you write? ts2. Okay, what is the objects order will come? C, B, A. Control F11. Look at there. Output coming what? CBA. Last one coming what? CBA. Understood, everyone? Now, let me explain how the execution is going on. Tell me, first, this object is added directly. Okay. Second object is added. How? String comparator dot. You have to call compare method, na? Because I am passing compare. So which method is used to compare? Compare. Default comparison is not used. But comparator is available in adding object, past argument object, argument object. So use string comparator dot compare of. What I should pass here? Double quotes A, first object, comma, double quote, sorry, first object is what? C, comma, double quotes A, already available. Then implicitly, our comparator is comparing what? Double quotes A minus double quotes C, because we have written that logic in string comparator, na? What is written? S2. What is S2? Double quotes A. Double quotes A minus double quotes C. What written? Negative. Negative means which side stored? Left. Okay. So left means what is coming here? Here what is the first available? First available what? A. Here what is coming? Square bracket C, comma A. Then next tell me. Now str comparator dot, come on, participate. Compare of, what do you write? Double quotes B, comma, double quotes A. A na, first A na. Then compare with what? Double quotes A minus double quotes B. B na, yeah. Right, B we are adding. Then what happened? Returns what? Negative. Negative means what? Left side. Left side already element available, no? Again, this comparison is repeated. strmpr string comparator dot, what do you write? Compare of double quotes again B compared with left side object double quotes C. What happened here? Double quotes C minus double quotes B returns what? Negative or positive? Positive. Positive means what? Right side. Positive means what? Right side. Positive means right side. Right side means what is coming? Square bracket C position C only, comma B, comma A. So this is how internally it will work. So I understood how to store my string objects in default sorting order, ascending order. Tell me, the default sorting order, ascending order is the tree set order or string object order? Come on. Reset order, string object order, string object, not reset. Already you have read the point. The tree set doesn't have any default sorting order. The natural sorting order of tree set is adding objects, supplied sorting order. String class applied sorting order is ascending order. Yeah, wrapper class of supplying order is what? Ascending order. Okay, then how can we supply the ascending order or descending order? For that, tree set internally using two interfaces, comparable and comparator. In string class, comparable interface is implemented to supply comparative method with ascending order. If you don't like, then implement comparator interface to supply the logic in descending order. That's what we are doing here. So hope you understand this. Then tell me. Now I am asking you to store integer objects. Tell me, if I take integer objects, then integer objects default sorting order is what? Ascending order. Integer objects default sorting order is ascending order. Then if we store integer objects, they are stored in which order? Ascending order only. Look at there, 5, 6, 7. I don't like ascending order. I want a descending order. If you want a descending order, what you have to do? If you want a descending order, what you have to do? You must supply custom comparator. Help me to write the code for supplying custom comparator here. Tree set, copy paste. Here, what method is called internally? Compare to, because there is no comparator argument. Then I want to pass TS4. Okay, TS3. Let me change to TS4. Same objects, I want to store descending order. Help me. How many ways we can implement comparator? 4 ways. First way is what? Outer class. Second way is what? Anonymous inner class. Tell me, what is the syntax of anonymous inner class? New keyword following by interface. New keyword following by interface. Of which type objects you want? Integer. Which method you have to implement? Compare. What is the first parameter? Integer I1. Second parameter, integer I2. Now, what you have to return? You should return. You want to store objects in ascending order, descending order? Descending. Descending means second object minus first object. These are integers, na? These are integers. So directly I can use minus operator. But previously we cannot use minus operator directly because they are string objects. Here, these are integer objects you can use, or you can also use dot comparative, because comparative method already implemented in integer class. I can reuse a comparative method, but comparative method usage takes what? A lot of execution time. Better you can directly write minus operator, your wish. Okay, anything you can write. Then tell me. Now, if you write TS4, what the flow of execution? First object is just added directly. Okay, first object directly added. Second object, tell me, integer comparator dot, What method is called? Compare of what value is coming here? 7 comma 5. Then what is the logic we have written? 7 comma 5 or 5 minus 7? 5 minus 7. Reverse order. 5 minus 7. Okay. Then what is the value coming? Negative. Negative means left. Left means what? Here already available object is what? In collection 5. Okay. Now 7 stored left. 7 comma 5. Then next again same code is repeated here implicitly in the add method. Compare method is called compare of by passing what? 6. First object is 6 comma 5. Then 5 comma 6 comma 6 minus 5 returns what? Compare of no. First passing object is 6 na buddy. Okay. Here. 5 minus 6. What is value? Negative. Left. The left side already one object available. Then now here this code is repeated again. In comparator, what is passed? 6 comma 7. Then 7 comma 7 minus 6. Then what? Positive. Positive means what? Right. Right means then 7 right side, 5 left side, 6 is stored. This is the final output. Correct? 7, 6, 5. Line number, please. 102. 105. Here I want. Control F. Okay. 7, 6, 5 come. Everyone understand? Okay. Tell me, what is the default sorting order of tree set? Given object sorting order. What are the objects you are storing? String. Or what objects you are storing? Wrapper class. String and wrapper classes compare the objects by using ascending order. The default sorting order of string and wrapper class, ascending order. Now, like string and wrapper classes, can I store our own class objects? Can I store our own class object, example class object? If you want to store example class object, what is required? What is the basic rule to store any class objects in the tree set? What is the basic rule to store any class object in the array? What is the basic rule to store any objects to store in the tree set? It must be either subclass of comparable or supply with what? Comparator. Tell me. Here, example is not a comparable type. Yes or no? Then we cannot store its objects in tree set. It leads to runtime error, class cast exception. Observe. Java.lang. Class cast exception. Class EX cannot be cast to which type? Comparable. Why should I cast? Because to call comparable method, to call comparative method on this object, compulsory should be cast to comparable. Na? Then what is the solution? Nothing. Just a comment. And another commented. And then if you want to add 2 options, either go to example class and implement comparable. No, I don't want to implement comparable. Avuna? Then what you do? Supply what to do? Supply comparator. Supply custom comparator. How to supply custom comparator? Here I should, can I use lambda expression now? Because here I taught you one outer class, Second, anonymous inner class. Third, lambda expression. Tell me how to develop lambda expression. Lambda expression means anonymous inner class shortcut way na. I should remove this much syntax. Only take what? Parameters. What parameters? E1, comma, E2. Can I directly write parameter names? Yes. Parameter type is not required. What type of objects these are? What type of objects coming to the comparator? Example. E1, comma, E2. Here already you specify the example. Na? Then the type of is what? E1, comma, E2, arrow. What do you write? You want to store example objects in which order? Ascending order. Ascending order in which property? X property. E1 dot, what I call? Get X minus E2 dot get X. Khatam. Any exception or no exception? No exception. X property wise ascending order. X property wise ascending order. Control. Okay. First, look at their objects are stored X property wise ascending order. 5, 6, 7. What? Huh? First digit compare. What you have written, man? Array. What you have written here? You are comparing which bar property? X value you are comparing. What is the X value? 5. Next 7. Next 6. What is the order? 5, 6, 7. Are vachindi 5, 6, 7. Oh, you are seeing this is 6. Oh, talented ga. Sorry, let me change this value to some other value. 4 let me take. Okay na? 5, 6, 7. Okay. 4, 8. This also ascending na? No, 3 coming here. Not on Y property, on X property. Now redevelop this code to store X property descending order. What do you have to do? X property descending order. Simply E2 minus E1. Supplying custom comparator X property wise descending order. Okay. Look at that. X property descending order. 7, 6, 5. Okay na? Bob online students, are you following? Any confusion? Can you tell me to store example objects? Y property ascending order possible? Yes, sir. What I have to do? What do you have to do? Here, X place what? E1, X place what? Y. E2, X place what? Y. And then this is Y property wise descending or ascending or ascending or. Now you think, how many default sorting orders I can write? 1. How many custom sorting orders I can write? Multiple. Every time what you have to do? Change the lambda expression, its property. Ante. Now what is the output will get? Y property ascending order. 3, 4, 8. Okay. Now if you want Y property descending order, what to do? Do you need to do any change in the code? No. Simply you have to change object E2, E1. Okay, Y property descending order. Now Y property descending order 843. 8, 4. Okay, na? So that symbol reset is. Understood? No, sir, I want to supply default sorting order. Okay. To supply this default sorting order, do like this. I have created one class called what? Sample. I created one class called sample. Okay. In sample class, what to do? Implements comparable. Sample implements comparable. Then override comparative method. We have already overridden hash code and equals methods for set. Remember? Now I want to store in sorted set. So we are overriding comparative method. Into comparative method, how many objects coming? 2. First object, current object, second object is element. This equal to argument object. S equal to element. Now return this minus x minus s dot x. Current object dot argument object. Then current object minus argument object ascending order. No, I want to make default sorting order is descending order. Then write current argument object minus current object. So tell me, default sorting order, is it default sorting order is ascending order or the supplied order? Supplied. Generally in the real life, ascending order everybody follows. That's why we are writing ascending order. If you don't like ascending order, then you can change to descending order. Okay. Now sample class is implementing from comparable. Now it has a permission to store in the tree set object. Yes. We can store in tree set object. Any class cast exception? No. Objects are storing which order? 5, 6, 7. 5, 6, 7. Okay. Five, 6, 7. Then now tell me here execution flow is same. Already you know the execution. I don't like ascending order. I want custom comparator to supply to this collection. What to do? Simple. Alt F. I have seen the tree sample class already having default implementation, but the default implementation I don't like. Then what to do? Provide custom comparator by lambda expression. S1 comma S2 arrow S1 dot get X minus S2 dot get X. Then tell me, is it ascending order or descending order? This logic is ascending order or descending order? Ascending order. 5, 6, 7. What do you want? Descending order. Descending order means what do you write? Second object minus argument object. Second object minus first object. Now you will get descending order. 7, 6, 5. So this is the complete story working with a tree set. Okay. This is the story about working with both comparable and custom comparable. Last class I have already uploaded all these files. Let's see whether uploaded or not. Enum set. Oh, yeah. Tree set internals, custom comparator, different between comparable and comparator. Check once. Difference between comparable and comparator. First point. Comparable is used for providing natural sorting order or default sorting order. Comparator is used for providing custom sorting order. Comparable contains compare to param method for providing objects comparison logic. Comparator contains compare object comma object param method for providing objects comparison logic. By default, reset.add invokes comparable.compare2 method when we are adding objects. ts.add method invokes comparator.compare only when we pass it as argument explicitly by using tree set of comparator and constructor. Comparable is available in java.lang from 1.2 version. Comparator also available in java.util package from 1.2 version. Both are helping for tree set. Both interfaces are functional interfaces. SAM, single abstract method. Comparable is not explicitly declared by using functional interface because comparable is not used as a method or constructor parameter for passing its implementation class instances. Whereas comparator is declared with functional interface annotation. Both are functional interface. They have only one method, but comparable is not explicitly declared because it is meant for implementing by one class, but not by providing as an argument. Comparable interface has only one method that is compared to. It doesn't have any additional Java 8 default or static or private method. But in comparator interface, in addition to compare method, it has another abstract method equals and several Java 8 version default and static methods. You can ignore them, not required to learn. Okay, na? Okay. By this time, whatever you learn with this only, your brain is blasty. Then unnecessary extra stuff not required. After you get the job, in company if required something, you can explore and try to learn by your own. So this is the story about tree set. So simple point, wherever sorting is required, if you want to store objects in sorting order, number one, first what you have to come to your mind, comparable. Number two, comparator. Okay, comparable, comparator. Then number three, what? Tree set. Number four, sort method. Okay, now there are some methods which are, there is a method called what? Sort. I don't want to use a tree set. I want to use what? Array list. AL equal to new array list. Tell me, array list, AL dot add of 5. AL dot add of 7. Okay, and next AL dot add of 6. Then if I write system dot outer println AL, Bolo, does it store objects in sorting order? No. It maintains objects in which order? Insertion order. What is the insertion order? 5, 6, 7. Okay. Now you tell me, I want to store objects in array list in sorting order. Then AL dot add of which sorting order? Sorry, AL dot sort of which sorting order? Ascending order. Ascending order is the default sorting order of integer. Na? Do we need to provide any custom sorting? No. Then what you write? Simply null. Null means what? You are not passing any custom comparator. Not passing custom comparator. Okay. Uses default sorting order in bracket ASC given in which class? Integer class. No, I want to store objects in descending order. This is system.out.println AL. If you write, objects are sorted. What is coming? Square bracket. Five, 7, 6. Now here objects are stored in which order? 5, 6, 7. Okay, na? Very, very important. No, I want objects stored in descending order. Then you should pass what? Custom comparator. What is that? Bracket I1, I2, arrow I1, I2 minus I1. That's all. I2 minus I1. This is a lambda expression implementation for integer. Then if you write system dot out dot println AL, objects are coming in which order? Descending order. What is that? 7 comma 6 comma 5. Understand? Here I should create array list object. Which order? AL of integer, AL equal to new, AL of. Okay, online students, all you people understand? Whenever you say sorting, how many things should come to your mind? 4. Number 1, comparable for default sorting order. Comparator for custom sorting order. Next, tree set, storing purpose. Sort method, sorting purpose. Storing and sorting. Okay. Please write down this. Let me write again. For sorting objects, we must use below 4 things. Number 1, comparable interface for supplying Completed? Huh? Completed? Huh? So with this, we strongly understood sorting related concepts in our Java. Okay. Whenever you want to sort, you have to bring into your mind. First, you have to check the class is implementing comparable. If not, you have to write your own class implementing comparator for comparing this class objects, and then create tree set class objects to store. Or if already you have objects in normal collection to sort objects in normal collection, you have to pass this custom comparator to sort method. With this, we understood sorting logic thoroughly. Okay, online students, everyone got clarity here? Okay, I need more 3 hours class. Okay, I need more 3 hours class for completing map. Okay, hash map internals and its implementation. So I need 3 hours class. So is it okay if I take 3 hours class next Sunday instead of daily half an hour? Is it okay to all? Sunday 9 a.m. 9 a.m. no 8 a.m. I want. Sunday, next Sunday, coming Sunday means 19th na 8 a.m. to 8 a.m. to okay till the 3 hours completed or required if 1 or 2 hours extra. Is it okay to all? Offline students, okay na? Online students, are you also okay na? Instead of half an hour, your time is wasting unnecessary. You can spend time for revising. So what I'm expecting all the people, please revise all the topics you learn in core Java. Okay. By Sunday, you are coming back. You should come with a strong revision of entire core Java so that I will teach you the map, and if required, we will also develop one small project. Actually, nowadays, core Java project I push to advanced Java to save your time. In advanced Java also I have to teach project. So in now, whatever the projects I'm missing in core Java, I'm adding in advanced Java and teaching everything. JDBC one project, servlets one project, combined one project. That way I'm covering. So we'll see if time permits, I will cover here. Otherwise in advanced Java, you can learn. Okay. So this Sunday, we will have class. If required, I will ask you to come on Saturday. Okay, na? So in group, I will let you know by Friday. Saturday, Sunday, or only Sunday, Friday, I'll let you know. Clear my point? Thank you. That's all for today class. Please practice. Reset compulsory. Okay. Thank you. See you all on Saturday and Sunday. Okay. Saturday, if required, I'll inform you. That's what. Keep it in mind. Thank you. Advanced Java, I'm waiting for management to announce. So maybe this week announcement may come expected. Thank you, guys.